This is the last 3 questions in the section. For some reason, they did not video correctly, and so I'm adding that. Number 6 is about the Chebyshev's theorem, that we use the formula within k standard deviations of the mean, and we have this formula that that's the fraction that will lie within k standard deviations. And so in our information it says use this to find the fraction of all numbers of a data set that must lie within 3 standard deviations. So that tells you your k in your formula is 3. So 1 minus 1 over 3 squared. That's 1 minus 1 over 9. And it wants your answer in an integer or fraction, not decimal. So 1 minus 1/9 is 8/9. This is the formula that you're using. It's right there as well. So 8/9 is what would go in your box. Number 7, the mean in a certain distribution is 40 and a standard deviation of 4. Use Chebyshev's theorem to tell the probability that a number is going to lie between 28 and 52. So if it's between 28 and 52, well, it's 12 less than the mean. The mean is 40. So if you take 28 from 40, you get 12. If you add 12 to 40, you get 52. So the number between there is 12 less than the mean and 12 greater. And how many standard deviations are in that? 12. 12 divided by 4, your standard deviation is 4, is 3. So you are within 3 standard deviations of the mean. So now that's your k, just like we did up here. So it's 1 minus 1 over 3 squared. That's 8/9, but in this one it wants a decimal. So go ahead and divide 8 by 9 on your calculator and you get 0.889. So that would be number 7. Number 8 has a little bit more to do. It says a medical lab tested 8 samples of human blood for acidity on the pH scale. And so here's the 8 samples. Find the mean and standard deviation and what percentage of the data is within 1 standard deviation of the mean. So you can find the mean and the standard deviation on your calculator. And so we have 7.3 as the mean, and the standard deviation is 0.1773. Now, to find the percentage that are within 1 standard deviation, so if we take the mean and we add a standard deviation, we get 7.4773. If we subtract the standard deviation, we get 7.1227. And so we're going to get our answer, but before we talk about the answer, let's talk about how we figured that out. So if you put your data in L1, second stat, go over to math, choose the mean, and you'll get, and second one tells you tells your calculator to get L1. That's where you get the 7.3. And then the standard deviation, it's second stat, math, and choose standard deviation of L1. And so that's how we got those. Then we want to find the upper, we found the upper and lower limits by adding and subtracting. That's what I did there, but here it's broken down a little bit more. Subtract 1 standard deviation and add 1. So we get these numbers. Now to find the number of samples whose points fall, whose pH fall between those, find the 5 items that fit in this area. So if we go back to our data, 7.1 does not fit in there because it's below this one, but 7.2 does, 7.4, there's another 7.2, another 7.4, and another 7.4. So there's 5 items that fall within those limits, and there were 8 total, so 5 out of 8 is 63%, and that is the answer for this part. So I think that will finish up 9.2 for us.